Welcome back. In the previous video, we have used EvoDAG library to automatically download low cloud cover Sentinel-2 image to a local drive. In this, we will learn about unzipping, selecting and saving Sentinel bands for processing, creating and mapping Normalized Difference Vegetation Index or NDVI. Let us start with unzipping or extracting zip file. We can import necessary libraries such as OS, globe, zip file, pathlib for handling path. To find compressed file, we can use try block with the next function. Then defining extraction directory folder named after the zip file using .stem. Then we can use zip file library, call extract all function to unpack the file. When I run this code, you can see the zip file is extracted in the folder. After unzipping, we have to select and save required bands for processing in another folder. We can import necessary libraries such as shuttle and pathlib. Let's define the necessary folder to save the Sentinel bands, extracted Sentinel bands. These are the bands that we want to import. And these Sentinel bands are complex.save folder structure. This is a standardized format Sentinel satellite use for archiving and distributing data, and which is located within the granule directory. Then we can use shuttle.copy file to copy .jp2 bands and rename and place them in a new Sentinel band extracted folder. When I run this code, you can see that Sentinel band is renamed and saved in Sentinel bands extracted folder. Next, to generating normalized difference vegetation index and saving it as GeoTIFF file, we need to import necessary libraries such as raster.io, matplotlib, .pyplot and numpy. So using globe, we can locate the red B04 and near infrared band B08 in the extraction folder. These bands are opened using raster.io and converted to numpy arrays has float64 data type. Finally, normalized difference vegetation index is calculated using standard formula, and the result is exported and saved as new GeoTIFF file. When I run this code, so you can see the red and near infrared bands are extracted. You can see the result is saved as a NDVI result in .geotiff format. Finally, to plot NDVI image with a legend scale, we can use matplotlib and raster.plot.show to render the NDVI map using defined color palette and legend representing color bar. When I run this code, you can see normalized difference vegetation index is rendered and mapped. The legend is given on the right side. This is how we can use Sentinel image for mapping and plotting normalized difference vegetation index. The code is given in the link below in the description. Please subscribe. Thanks for watching. Happy mapping.